This is a question from section 3.2, I believe number 4 in the homework. And so the question would look something like this. Solve the following linear programming problem. They want you to maximize this z function subject to these parameters. So using this form that's found under handouts, it's called the linear programming form, print that, and then the very first thing you want to do, first step, is take this maximize and write it down here in the right hand bottom block. That's the only thing you do first, put that there. Then you're going to take the parameters and go here. We're going to do the constraints and isolate y, so change them each to y. So 6x plus 3y less than or equal to 18, I'm going to subtract the 6x, then I'm going to divide by 3. So I have y is less than or equal to negative 2x plus 6. And then I do the same thing with the other one. And I subtract 8x, and then I have y is less than or equal to this. So now I have my two constraints right here. Now, you could graph this in your calculator, and you might even do that to check, but I would say go over here and try to attempt to sketch it by hand. So we're going to graph this line, y equals negative 2x plus 6. So this is your y-intercept, this is your slope. So that's my green line. I did color code it. And I went up here and I put a dot at 6. I came down 2 and over 1 and put a dot. And this doesn't have to be perfect. So I connected those, and then down here I wrote that that was the line y equals negative 2x plus 6. And you would shade to this side of that line. Then I did the same thing with this one. I went up a certain amount and said, okay, there's my 18. I went down 8 over 1, connected those, and so my red line is y equals negative 8x plus 18. And this x greater than 0 and y greater than 0 are equal to 0 tells me I'm only right here. So I stopped my lines there. So both of those were shaded here. And this is my feasible region. So I need this point, and this point right here. I don't think I have one marked right here. Let's see if we can put a dot there. Okay. So I need those 3 points. I've added them there because this is a completed one. But in order to get them, I came down here to the find intersections part. So now I want to take two things at a time and find where they intersect. If I'm going to take the negative 2x plus 6 and this one, so the red line and the green line, if they're both y equals, and I want to find where they intersect, I just set them equal to each other. So I did that and solved that for x and got x is 2. Then I took 2, plugged it in for x here. So that's what happened here, and I got a y. So that point is 2, 2, and I wrote it in there. Then for this green line and right here, for this point that I'm trying to find, I know that in this one, x is equal to 0 because that's a y-intercept. So x is equal to 0, so that's 0, 6. I can see that, but if I had to write it down here, I put both of those here, and if you plug in 0 for here, you get 6. So there's that point, 0, 6. This one is on the x-axis, so y is 0 here, and I'm intersecting the red one. So I've got y equals negative 8x plus 18, and y is 0. So negative 8x plus 18 has to equal 0. I'm going to move the 18 over here, divide by it, and I end up with 9/4. So there's my other point. Once you have your 3 points of your region, you come over here and you write those 3 points. So 2, 2, 0, 6, 9/4, 0. You're going to plug them in to this maximizing function. We want to see which one gives us the biggest number. So I plug in 2 for x and 2 for y, and I get 10. I plug in 0 for x, 6 for y, 9/4 for x, and 0 for y. and my largest is 10. So the question actually says, what is the max value? And so that'll be your 10. And the second part of that will say, where does that occur? And that will be your ordered pair, 2, 2. So I would use this form for number 4 and number 5 in 3.2, and then we'll use it again in 3.3. So get familiar. I think it will help you organize your information. All right.